In this lesson, we're going to talk about graphing other trigonometric functions. So we've already done sine and cosine. So we're going to be looking at tangent, and then all of those cotangent, cosecant, and secants, and see how they kind of relate to the kind of base functions of sine, cosine, and tangent. So we're going to first start off by looking at how we graph tangent. And just like with sine and cosine, we do want to use the unit circle. And we want to remember tangent from our unit circle is that y over x. So if we think about each of the points on your unit circle as an x comma y, right, your rise and your run, tangent is the y over x. So if we just take a quick look at the unit circle, we can see which points are actually really easy to graph, because we don't want to end up graphing things like, square root 2 over 2 or 1 over square root 3. Those are kind of annoying, and much easier to graph things like 0, 1/2, 1. So let's take a look at the unit circle and see what we can do with tangent. All right, so here's my unit circle. And what I want to do is I want to start usually right at 0. It's a nice place to start and see what we can do. So remember, we're looking at tangent. So tangent is going to be that y over x. So if we're looking at tangent of 0, that's going to be 0 over 1, which is super easy to graph. So then we have a coordinate, we can go 0, 0, right? So that's what I'm looking for. I'm looking for nice, easy numbers. So if I go up to that pi over 6 or 30 degrees, I don't want to deal with that radical 1/2 over square root 3 over 2, right? If you imagine this tangent of pi over 6, it's 1/2 over square root 3 over 2. Those denominators cancel out, but I'm still left with 1 over square root 3 or square root 3 over 3. And if I want to graph that, it's like, now I have to estimate that and figure out what's the square root 3 over 3, and that's not super fun to do. So I would say let's skip that, right? So you can see I'm just kind of going around my unit circle looking for good numbers. So now if I move on to tangent of pi over 4 or 45, you might notice, hey, even though we have a square root, they're the exact same value. Square root 2 over 2 over square root 2 over 2 is like the same thing as saying 1 over 1 or 3 over 3. It's the same thing on top, same thing on the bottom. That just reduces down to 1, right? Simplifies down to 1. So then we can graph the point pi over 4 comma 1 super easily, right? And we can use the same logic, and you can find, okay, let's do tangent of pi over 2. Well, then we have y over x, 1 over 0. Anything with the 0 leads us to an asymptote because that's undefined. So x equals pi over 2 is an asymptote. All right? And then we can keep going and skip this way. But if you remember back to when we talked about the inverse function of tangent, I said, hey, remember, we're limiting our domain to 90 to negative 90. And you might realize why that is now, because if I go past this 90 degrees and go on to that 120 or 2 pi over 3, I'm going to skip that asymptote, right? I'm going to have a break. But if I want to have one nice continuous piece for tangent, I'm going to go down, because you'll realize we can get more numbers to graph this way. So if I go down to this 11 pi over 6, remember, is just this negative pi over 6. So then thinking along the same lines, this 7 pi over 4 is basically your negative pi over 4. Then we have negative pi over 3 and so on. So, but I really only care about the points that will give me nice coordinates, right? Like the 0, 0 or pi over 4 and 1. So I actually don't care about the pi over 6, right? The 5 pi over 3. I'm just going to be looking at that 45, that negative 45. So that pi over 4, that negative pi over 4. And then coming down to this negative pi over 2, right? Because we end up with the same kind of ratios. If I'm looking at tangent of negative pi over 4, that's going to be negative root 2 over 2 over root 2 over 2, which is the same thing as negative 1 over 1, which simplifies down to negative 1. So we have another nice easy coordinate, negative pi over 4 comma negative 1. So you can see how it just continues. And then I can look at, okay, let's look at tangent of negative pi over 2 to get negative 1 over 0 to get a second asymptote. So then x equals negative pi over 2 is an asymptote. So then I can create one full period, going from asymptote to asymptote, just going from top to bottom. So let me kind of clean this up, show you the coordinates I'm going to graph, and then we'll actually go ahead and graph our tangent. All right, so just kind of took that information from that unit circle we were just looking at and cleaned it up a bit. So really I have 3 key points to graph. This negative pi over 4 comma negative 1, 0, 0, pi over 4 comma 1, and then 2 asymptotes I got out from that quadrant 1 and quadrant 4 from the unit circle. So that creates actually one full period because our period goes from asymptote to asymptote. So what's interesting about this is a full period is actually just pi for tangent. So if you remember for sine and cosine, our base function there had a period of 2 pi. Tangent is actually just pi. It's going to go from negative pi over 2 to pi over 2. So let's go ahead and graph this. Remember, I do want you guys to graph 2 full periods typically. So if one full period goes from, negative pi over 2 to pi over 2, we want to make sure we repeat that. I want to make sure I can get a good scale on my x-axis to fit 2 periods, but also to make it easier to graph. So I'm going to go ahead and go by, let's say, pi over 8. So then pi over 8, this will be negative pi over 4. And then pi over 8, pi over, oops. I wrote pi over 2 when I said pi over 4. So that's pi over 4. And this one will be pi over 4 as well. And then skip over, so we'll get pi over 2. And then negative pi over 2. So I'm going to go ahead and graph my first period. And I'll do this in, let's say, this pink color. So remember asymptotes, let's go ahead and graph as a dotted line. And since our asymptote is x equals pi over 2 and x equals negative pi over 2, we're going to use vertical lines there. And then I can go ahead and graph those 3 key points. So 0, 0, pi over 4, and let's make this go up by 1/2. So we'll put 1 here and negative 1 here. So pi over 4 and positive 1, negative pi over 4 and negative 1. And then remember, our trig functions are going to be graphed as curves. So don't make this a straight line and be like, wait, I'm going to run into those asymptotes. Remember, we want to approach the asymptote, get close to it, but never pass it. So we know this is going to be a curve. So we're also going to curve this way. And then tangent is basically this kind of S curve. And we're going to repeat that. So again, I want 2 full periods. So let's keep going. So we're going to get pi there. Oops. Sorry, pi is actually the next one over. This should be 3 pi over 4 because I'm going by 1/8. So I'm going to skip 1 and go up by a 4th. So 3 pi over 4. Then pi's here. And then we'll have 5 pi over 4. Right? And then if you just count your tick marks, this is actually the easier way of doing a period. So it's 1, 2, 3, 4, 5, 6, 7, 8. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. So I need to go 1 more over to finish that off. So then I will get 6 pi over 4 or 3 pi over 2. And then we're just going to basically repeat it. So you don't actually have to go through and go around your unit circle every time to get these points. We'll just say, okay, well, this repeats because it's a periodic function. So then if I just take this negative pi over 4 and negative 1 and just go 8 over, I'm going to get my next point. This is 3 pi over 4 and negative 1, right? I can do the same thing going from 0 and the same thing going from pi over 2. And then going with my asymptote as well. So just counting a full period over to get our next set of points. And there is your graph of tangent. Okay, so then what about cotangent? Well, cotangent, remember, is related to tangent. Cotangent is just 1 over tangent, right? So cotangent is basically x over y. We're just doing the reverse, all right, the inverse of tangent. So we are flipping x and y. So now you'll notice some things have changed. So if I go back up, right, or actually, let me show you that unit circle again. We can't necessarily do the same ratio. So now instead of tangent 0, 0 over 1 is 0, we're going to notice cotangent of 0 becomes 1 over 0, right? So then we're switching around our asymptotes and all that. So what's interesting here is what used to be the x-intercepts of tangent now become the asymptotes of cotangent. And that's simply because we are flipping around your x and your y. So instead of having 0 over 1, we now have 1 over 0, which is undefined, right? And then we'll notice that the asymptotes of tangent become the x-intercepts of cotangent. Again, same reason, we're flipping it over. So now instead of 1 over 0, we have 0 over 1. So that's the big change. But then if we go back and look at, right, when I did this pi over 4 and negative pi over 4, that doesn't change. X over y, square root 2 over 2 over square root 2 over 2, still 1. This x over y, square root 2 over 2, divided by negative square root 2 over 2 for the negative pi over 4, it's still negative 1. So the pi over 4, negative pi over 4 is not going to change. What changes are the asymptotes and the x-intercepts. So what am I going to graph here? So let's adjust for cotangent x. So I'm just going to scroll up and show you guys the tangent function again. And remember, the x-intercepts of tangent now become the asymptote, and my period's going to go from asymptote to asymptote. So I'm not going to go from negative pi over 2 to pi over 2, just like tangent. I'm actually going to go from 0 to pi for my cotangent, because I want to kind of get one nice curve between my two asymptotes. So I'm going to actually start with that just to show you my asymptotes here. So I use the same scale for x and y, but what I'm going to show you now is the asymptotes are changing. So I'm going to shift kind of where my curve is going. So, right, the x-intercept of tangent becomes the asymptote of cotangent. So where I have 0, 0, x equals 0 is now an asymptote. So I'm going to graph that in orange. Okay, and then we can see here that we hit pi. So that means on the x-intercept there. So that means for cotangent, pi is another asymptote, right? And if I counted 8 spaces over, right, or I just do another full period, I'm going to be hitting 2 pi. So 2 pi is going to be my next asymptote. No, let me fix that because I counted my scale wrong. There you go. I forgot that 7 pi over 4. Sorry about that. So then if we go ahead and count, we should see we go a full 8 kind of spaces there to make one full period, and then I'm going to have another asymptote here at 2 pi. So my period is still pi, right? But what changes is my x-intercepts, which then changes where that curve goes. So remember, going back to the graph, my asymptotes of tangent are now going to be x-intercepts. So I'm going to go ahead and put an x-intercept at pi over 2 on the x. I'm going to put an x-intercept at 3 pi over 2. And then remember that pi over 4, negative pi over 4, those pieces haven't changed. So where we have pi over 4 and positive 1, I'm still going to have pi over 4 and positive 1. Where I have 3 pi over 4 and negative 1, I'm going to, ooh, sorry, I keep making mistakes here. That should be 3 pi over 4. My bad. We'll fix that. So we'll have 3 pi over 4 and negative 1. That also is there. So when we draw this curve, you're going to see it's kind of going the opposite direction of tangent. So it's going down from left to right rather than tangent going up from left to right. But I'm just basically taking these key points off tangent, right, to create my cotangent function. So once again here, I have my x-intercept at 3 pi over 2, and then we have 3 pi over 4 and negative 1, which I did already. So then I now have 5 pi over 4 and positive 1. And then you can see it's periodic, so I can just use this pattern. So then going kind of 2 spaces away from 3 pi over 2, I'm going to get that 7 pi over 4 and negative 1. And there's my second full period. And that is cotangent. So if you can graph tangent, you can get cotangent really easily, right? X-intercepts becomes asymptotes, vertical asymptotes. The negative 1 and 1, those points don't change. And your asymptotes become x-intercepts for cotangent. So there's our cotangent function. All right, so let's move on and think about how can we transform tangent and then also cotangent. So remember, with our transformations, this hasn't changed from everything we've talked about prior to this. So that A in front talks about your vertical stretch or compression. The B inside the tangent, right, that's in front of the x minus h, talks about your horizontal stretch or compression. That h is your horizontal shift. Remember, that's called a phase shift for some reason when we move into trig. And then K is that vertical shift up or down. So that hasn't changed at all. But really what we care about with tangent is because there is no real amplitude for tangent. So if you remember, just scrolling back up here, tangent's going to go on and on forever. up and down, which is why there was no kind of maximum or minimum to tangent, we don't worry about the amplitude like we would talk about with sine or cosine, right? There's no max or min. It goes on to positive infinity, negative infinity. So really what matters to us is what is the period. And then once we get the period down, we can figure out our asymptotes and we can figure out our key points. So what is the period? The period is going to be pi divided by the absolute value of b, because that horizontal stretch or compression, remember, that's kind of like, imagine an accordion. If we're going to push it tighter together or pull it out farther apart, that's going to affect our period. So the period is really the most important piece here. Remember, the period of tangent without any transformations is pi, so that's why we have pi on top and not 2 pi like we did with sine or cosine. So we're going to do pi divided by the absolute value of b, because that's going to tell us how much we're either stretching or compressing it horizontally. So just remember that 1 over b is that horizontal stretch or compression factor, so that's why we have b in the denominator. So that already accounts for that 1 over b. Okay, so then once we get that down, it's really, really straightforward to find the asymptote. So I'll show you what that formula is in a bit, but it's actually really intuitive. So if we go back up to our tangent function, if our entire period is pi, because it went from negative pi over 2 to pi over 2, you realize by dividing our period pi by 2, we get our asymptotes, right? Pi divided by 2 is pi over 2, right? And then we can add or subtract pi from that to get that entire period, or to find that asymptote, right? So I can say, hey, what's pi over 2 plus another pi? Well, that's 3 pi over 2. So there's my second asymptote. Pi over 2 minus pi is negative pi over 2. There's that asymptote. So really, you're just taking that period, dividing it by 2 to figure out what this asymptote here at pi over 2 will change, right, into, and then just add or subtract one whole period from that number, right? So I'll show you in the example in a bit. But again, you can find the asymptote using this formula, or just remember, we're going to find that first asymptote by dividing the period by 2 and then adding a full period or subtracting a full period from that. So again, what I've written down here is basically what I just told you. So this pi over 2 times the absolute value of b is basically taking your period, dividing it by 2 to get that first asymptote. And then we're going to add pi times n over b, and n is just how many periods you, I guess, a whole value, right, positive or negative, that'll be adding or subtracting a whole period from that base asymptote. So this is basically the length of one period. So we can add or subtract depending on if we are making n positive or negative. So you can remember that if you'd like, but I'll show you what I was talking about earlier. So if we look at this example 1, transforming this tangent, g of x equals 1/2 tangent of x over 3. This 1/2, we don't want to forget about it. It's going to affect our amplitude. Well, I shouldn't say amplitude because there really is no kind of higher lower value, but it's going to affect the y value. So we'll get to that in a bit. But what I want to look at first is where's my period, and then how do I figure out my asymptotes, because that's what I was just talking about. So we know the period is going to be pi over the absolute value of b. So if you want to rewrite this g of x is 1/2 of tangent of 1/3 x. So you can see b is 1/3. So I'm going to do the absolute value of 1/3 is my denominator. So that means the period is really just 3 pi. So then to find my asymptote, you can use that kind of formula earlier, but what I was saying is you can simply find that first asymptote. X is going to be 1/2 of the entire period. So that means my first asymptote is 3 pi over 2. So what I'm going to do then is I'm going to go ahead and make my x-axis scale, so then I can easily find all of my other asymptotes as well. So we know the length of the period is 3 pi, so I'm basically going to be adding and subtracting 3 pi from this value. So you can do that with the fraction if you'd like. I'm going to go ahead and figure out my scale because I need that anyway for my graph, and then figure out the other asymptotes to make my 2 full periods. I should also mention, if you want to figure out your x-intercepts first before doing your scale, you can totally do that. I spread it nice and wide because I only need 2 full periods and I have a lot of space. So you can say I went by pi over 4. So if my first asymptote is at x equals 3 pi over 2, that's 1.5 pi. So that's going to be right here, right? And then I want to go through an entire 3 pi. So if each of these tick marks is a quarter pi, right? 3 pi's would be 12 of those marks. So then my next asymptote would be right here. All right. And then I can count 12 to the left. And then I get an asymptote right there as well. So again, you can just add and subtract 3 pi, which I'll show you next, but you can also figure this out from the graph, which it's kind of up to you how you want to do that. So my first asymptote that I started with, though, was that one in the middle, that x equals 3 pi over 2. So the next asymptote I could do is 3 pi over 2 plus 3 pi. Remember, 3 pi is the same thing as 6 pi over 2. So that's going to give me 9 pi over 2, which is that one over here on the right. And then I can take that x equals 3 pi over 2 and subtract 6 pi over 2, which is the same as 3 pi, to get me negative 3 pi over 2, which is this one right here on the left. So either way you get it, we get our 3 asymptotes. All right. So now what we want to do is figure out the x-intercepts, those 2 other key points, and then we'll finish our function. So the x-intercept is actually very straightforward. As long as we don't have any phase shifts, so no movement left or right, they're not going to change. So if we go back to the original tangent function, our x-intercept was at 0 and then at pi, right? So, well, I should say it will change, but our first x-intercept here at 0 won't change. That pi will depend on the whole period. So let me take that back. So we'll just go ahead and start with that first x-intercept at 0, 0. Again, as long as there's no horizontal shift, no phase shifts, we're still going to start at 0, 0. Right? So I'm going to put my 0, 0 there. And then all you have to do is go 1 full period. That's the brilliance about these periodic functions. Everything is going to recycle in 1 full period. And we said a full period is 3 pi. 3 pi is 12 of my tick marks. So just counting to 12 or all the way to 3 pi, there's my second x-intercept. All right. And then the final thing we need to do is figure out how the other points change. So now if we go back, sorry, I keep scrolling back and forth, but how do we get this negative pi over 4 and pi over 4? Well, remember, this is 1/4 of a full period, right? 1/4 pi is pi over 4. So what I'm going to do is take that information and say, okay, well, now my period is 3 pi. So let me do 1/4 of 3 pi. That's going to give me 3 pi over 4, right? So then that 3 pi over 4 is normally where I'd be putting, 3 pi over 4 and 1. However, that's where this a value comes in. So that is how the y value of our coordinates will change. So remember how we would normally do pi over 4 and positive 1? Well, now we know that pi over 4 has transformed to 3 pi over 4. And then that positive 1 has transformed into 1/2 because of a. So now I'm going to go ahead and find 3 pi over 4, go up to positive 1/2. Well, let me be consistent with my colors here. And then we can do the same thing from the other side. So remember, if you know the shape of tangent, we can just kind of move it over and figure out, okay, negative 3 pi over 4, negative 1/2, right? To get that second point. And again, we're just doing a 1/4. So 1/4 of 3 pi, 2/4 of 3 pi, 3/4 of 3 pi. Give me those values. And because it's tangent and there's no reflection, we're going to go negative, 0, positive. And there we go. So there's one period of that function. And we can do the exact same thing here, right? So going a quarter to 3/4, right, from this 3 pi, so counting over 1, 2, 3. Going over 1, 2, 3, because a quarter of 12 is 3. And I'm using 12 from the number of tick marks for one period, and we get that whole function. So there's the transformation of tangent. Okay? So the transformation of cotangent, pretty much the same idea, except remember the asymptotes change, the x-intercepts change. So if you would like, you can totally graph tangent and then shift your x-intercepts and asymptotes. Or you can think about how if we look back at cotangent, our asymptote goes from 0 to pi rather than negative pi over 2 to pi over 2. So we're just looking at a different kind of start point. So with cotangent, our period is going to be pi divided by the absolute value of b. Right? So same as tangent, because our period is still the value of pi. What changes is where the asymptotes are. So our asymptotes is going to be x equals pi times n over the absolute value of b. And that's because our base asymptote, our first asymptote that we start with, unless there's a phase shift, is always going to be x equals 0, right? So then what's nice about that is our asymptote is basically going to be at every period, the end of every period. So 0 to pi, then to 2 pi, then to 3 pi for our base function. And then depending on whatever the horizontal stretch or compression is, the end of every period will become an asymptote, which is kind of nice. All right. So if I want to graph this example 2, we're going to graph g of x equals 2 times cotangent 3x. I'm going to find the period, identify the x-intercepts and the asymptotes, and again, we always want to graph 2 full periods. So what's nice about this is you'll realize, hey, there's no phase shift. No phase shift means we're going to start at 0. So that means my first asymptote will be x equals 0. And I'm kind of jumping the gun here because we also need to know the period. So let me do that next. So the period is going to be pi divided by the absolute value of b. So that's pi over 3. So once I know my first asymptote is 0 because there's no phase shift, then my asymptotes are just going to go incrementally based on the period. So my next asymptote will be pi over 3. And then the next asymptote will be 2 pi over 3, because every full period will stop at an asymptote for cotangent, right? So then what might be tricky with this is you might be wondering, wait, where are my points going to go? Well, remember, if we look back at cotangent, just like tangent, each of these key points for pi over 4, pi over 2, 3 pi over 4 is 1/4 of the full period of pi. So if we know that our period here now is pi over 3, then the coordinates we want to work with, our x values, are going to be quarters, right, of pi over 3. So we're going to do 1/4 of pi over 3 to get pi over 12. 1/2 of pi over 3 will give us pi over 6. And then 3/4 of pi over 3 will give us pi over 4, right? So that's basically what your pi over 2 has turned into pi over 12, or sorry, pi over 4 has turned into pi over 12. Pi over 2 has turned into pi over 6, right? And then your 3 pi over 4 has turned into pi over 4. And then what are those corresponding points? Well, that's where, again, the amplitude comes in. So remember, with cotangent, we're going to go negative, positive, negative, because we're going to go up from left, or I'm sorry, positive, 0, negative. We're going to go down. Okay, so now that we have our x values, what are those corresponding points? Well, remember with cotangent, let me scroll back up, it's kind of the opposite of tangent. So we're going to go down from left to right. So that original pi over 4 corresponds or pairs up with 1. So that coordinate was pi over 4 comma 1. And that 1 or negative 1, right, is affected by the a value. So we're basically going to multiply 1 and negative 1 by the a, and we'll see we go from positive to 0 and then to the negative to get the curve for cotangent. So here my a value is 2. So that means I'm going to go positive 0, negative. So that means this first coordinate, pi over 12, is going to go with the positive 2, because 2 times 1 is 2. Right? This pi over 6, which is right in the middle, is my x-intercept. And then this pi over 4 is going to be at negative 2, because I'm going to go down from left to right. And then we can go ahead and repeat that whole cycle for the second period. So let me go ahead and figure out my x-axis and then start graphing my cotangent. All right, so I went ahead and went by pi over 24 because I can spread that out and make it nice and clear, and then I can hit all my key points on my x-axis. So I drew a full 2 periods from pi 0, oh, I didn't write my 0 in, from 0 to 2 pi over 3. And then you can count those tick marks and we can see, okay, one full period is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait, I went too far. 1, 2, 3, 4, 5, 6, 8, 7, 8. So 8 tick marks is one full period, right? So let's go ahead and draw in my asymptotes. My asymptote's going to be here at x equals 0, x equals pi over 3, and x equals 2 pi over 3. And we can see there should be evenly spaced out because it's one full period, one full cycle, should have the same number of little tick marks there on the x-axis. And then I can go ahead and graph my points. So pi over 12 and 2, pi over 6 and 0, pi over 4 and negative 2. And there's my first curve, right? And then we can count 8 tick marks to get the next set of points. So counting over 8 or just adding in pi over 3, whatever you're more comfortable with. I'm just going to count because I have it all here. There you go. And there is my second cycle. And hopefully your curves look a little better than mine because I'm just doing that really quickly. But we want to make that kind of that S squiggle approaching our asymptotes. Okay, so that wraps up cotangent and tangent. So remember, if you have any questions, definitely feel free to ask. We'll be doing cosecant and secant next.